Hi everybody, in this video we're going to be walking through your MATHia workspace called Rotations and Reflections on the Plane. So as the title of the workspace hints at, we're going to be looking at rotations and reflections. Here we're looking at some symmetry. So let's read through our left side. If a single reflection of a figure across a line of reflection transforms that figure onto itself, the figure is said to have reflectional symmetry. And the line of reflection is called a line of symmetry. For example, the circle shown has a reflectional symmetry. One side of the reflection is shown. So as you can see here, if I were to put this line, this is called our line of symmetry. Both halves should be exactly the same. When the circle is reflected across a line of symmetry, the resulting image is in the same position as the original. Does this circle have any other lines of symmetry? Do all shapes have at least one line of symmetry? So on our right side, we're going to study this example and then answer the questions. Select all of the lines which are lines of reflection for the rectangle. So for our rectangle, we see that we have, equal parts on some parts. For sure on this one, if I were to say that I wanted to reflect or cut my rectangle in half right here, it would be equal on both sides. Same goes for when we do it horizontally like this. If I cut through the middle this way, it would also be in half and the same on both sides. But thinking about the way that a rectangle is, if I were to reflect or fold this in half where this line is down the diagonal, our corners J and L won't match up. They're going to be in different spots. So those diagonals here and also here are not going to be lines of symmetry because they don't match up exactly. So just the vertical line and the horizontal line through my rectangle are lines of symmetry. Okay, now let's see for a trapezoid. So kind of going along the same things, I want to make sure that if I were to visualize, for example, this line as the line of symmetry, if you think about folding that shape in half there, would both of the sides match up perfectly? In this case, for my vertical line, that would be yes. But my horizontal line, let's find the box for the horizontal line. It doesn't seem to be anymore. Because as you notice, for a trapezoid, if I were to fold along the diagonal, this side is way too short for this side. Same thing if I were to fold along this diagonal, C part is too short for my A part. And folding it horizontally, we have two different lengths of my trapezoid on this side and this side, so it wouldn't be perfectly folded in half. Select all of the lines which are lines of symmetry for this regular pentagon. So let's take a look. If I folded along this line that it's showing, I believe it looks like all of my pieces would line up nicely. So I'm going to select that one. And I could also select this one. I would select this one, and this one, and this one. So noticing too, for a pentagon, as long as it's going through one of the corners and through the middle of the opposite side, it is going to be folded in half perfectly. And that's the end for this question. So you can press I'm done. And we would move on to the next question of your rotations and reflections on the plane. Now we're talking about rotational symmetry. If a single rotation of a figure around a point of rotation transforms that figure onto itself, the figure is said to have rotational symmetry. If the degree of rotation is not zero, or multiples of 360, for example, the square shown has rotational symmetry. So as we see it go around, it is actually going in increments of 90 degrees when it reaches um, the same shape and direction. When the point of rotation is at the center of the square, the rotation of 90 degrees, 180, and 270, and so on, carries the square onto itself. So here, we're going to try out some with these other shapes. Suppose this trapezoid is rotated about a point at its center. A rotation of blank will carry the trapezoid back onto itself. So let's look at our options. If I went 90 degrees, this long side would expect to be facing either here or here, depending which way you wanted to rotate it. So that's not the same as what this trapezoid is. If I went 180 degrees, then this long side is now going to face the bottom, which is not exactly the way that my pre-image is. So not there either. 270 is sort of an iteration of 90, where it's either going to be facing this way or this way, my long edge, depending on which way you rotated. So not 270. The only way we can rotate this trapezoid so that it is exactly the same again is if we went all the way around 360 degrees. Suppose this parallelogram is rotated about a point at its center. A rotation of blank will carry the parallelogram onto itself. So thinking about this, and the fact that it is slanted is going to be a little worrisome for us. So if we rotated it this way, 90 degrees, my double slash marks are going to be on the left and right side. Therefore, it's not the same parallelogram anymore. If I rotated it one more time to 180 degrees, we should see something that looks exactly like this one more time. So I believe we can go 180 degrees. And then 270, again, just another iteration of 90, where it's going to end up on its side with my double slash marks on left and right sides. We could have also gone in 360-degree increments because that is an iteration of 180. A rotation of blank will carry every figure back onto itself. So as long as we go 0 or multiples of 360, meaning you're rotating it all the way back around every single time, you'll always get that same image again. So we have finished this question. You can press I'm done. And there are still 2 more questions left in this workspace for you to work out. If you need any other help, make sure you use your hints, utilize any step-by-steps or sample problems that are also offered to you.